Today I'm going to describe a very short script and tool, short but powerful tool that I made during my company's hackathon. The problem I'm trying to solve is to speed up the process of working with LLMs. So I use LLMs every single day to often to do data analysis. So I'll ask the LLM to help me accelerate my coding, which is mostly in SQL, and I'll ask for code that describes the answer to certain questions I have about different data problems in the crypto space. And this really helps with my job, which is to help my company figure out what to do and also how to do it. One really important part of working with LLMs for data analysis is you need to provide them context. So this is an example of a pretty bad prompt. I say, from the blocks and transactions table, but in SQL you need to identify the specific name of the resource that you're querying. And then can you find certain information? And again, in SQL you need the specific names of each column. And some of these are intuitive, so I'm asking for the count of each transaction type. And so you can imagine that there's probably some kind of column that's called transaction type. And it's probably transaction underscore type, and it actually is. But if we run this right here, because it doesn't have context about what these things are actually called, it's not going to be very useful. So it's kind of bugging here. But you can see that, for example, this is the table name. And this is not the right name of the table. So for example, this is not the right name of the table. And so if I were to take this code and try to execute it in BigQuery, it's not going to work. For example, there's no column named block number in this table. This table doesn't even exist. So it failed at like the third line. And so this is okay. It kind of generally describes the framework. But if I were to use this, I would have to go through and edit this column name. I'd have to go through and edit this, data set name, etc. And so it just slows down the pace of iteration. One way to work with LLMs for this is, which is what I used to do before this tool, is to upload pictures of the data sets. And so here is a table that describes the hourly prices of major tokens like WETH, WBTC, USDC, etc. And so what I used to do is I'll upload this image into the context window, and that's my way of passing the table schema to the LLM. But that has a few drawbacks. First, you can only upload 4 pictures at a time, so if you're using many, many tables, then it's not going to work. Second, images are less token dense than text, and so it kind of lengthens your context window unnecessarily or inefficiently. And then lastly, the LLM has to change the image into textual tokens, which can cause more errors and is maybe less precise sometimes. Usually pretty good. One kind of standard in the AI industry that has arisen to fix this problem is the LLMs.txt file. This is a very concise document that compresses information for an LLM that you can use to work with different websites, APIs, etc. So here's an example of Anthropic's LLMs.txt file. And you can see it's in Markdown. It lists out the kind of major things that an LLM might get asked to do without as much description as might be necessary, or certainly formatting as might be necessary for a human reader. But it's a very concise, very useful artifact. And so my project was to make a similar artifact that was reusable, that could be used to generate these kinds of files based on the specific data that I work with every day. So it's a very simple command line tool. It uses the Google Cloud APIs to extract the table schemas of tables in which you're interested and then formats it into a single text document. So let's go run this. we'll grab the sample code. And here in the first line, we're going to run it with somewhat verbose logging with info so we can see what's happening. We're going to specify where my credentials are, which is it's just kind of specific to me. Shit. Okay, that's not going to work. Okay, sorry. We specify the tables that we want, so we're going to specify 3 tables: the transactions table for Ethereum, the logs table for Ethereum, as well as the blocks table for Ethereum. And this is all Google public data, so you can do it at home as well. And then we're going to call the output file gbq-llms.txt. So you can see that we start the application, we authenticate with Google, and then we successfully add these data sets. We get the schema for each, and then we write them to a text file. And so if we go, we can see the text file is in the same folder as the program that we're running. And this is what it looks like. So we have the full name of the table, so we never have to change that. The name of each column, the data type, which is really important. So for example, Google was pretty strict with data types. So for example, you can't, if it's a timestamp, you can't use date functions on it. So it's very important to have the right data type. And we have it for all 3 tables that we asked for: transactions, logs, and blocks. So let's try to run the same query, or run the same prompt rather, but this time we're going to provide a context from the file that we just produced. The goal here is to get a piece of code that is what I call one-shot. And so ideally, we can take the code that the LLM gives us, and it'll be right, and we'll execute, and will be accurate from the start without us having to do anything. And that obviously will speed up the pace at which we can work with an LLM, analyze data, and produce analyses. So again, it's a little bit buggy, but you can see, for example, that the table name is now accurate. So this is what the table is actually called: BigQuery-public data.google. You can read it, and hopefully there are some other. Hopefully this will execute right away. And there we go. So we didn't have to do anything. So if you're going to use this for data analysis, then you would actually want to read the code and make sure that it's doing exactly what you think it's doing, because you're the one who owns your own work, and you need to make sure that even if an LLM provided something for you, or in fact maybe because an LLM provided something for you, that it's actually doing what it says it's doing, because you're going to be the one who owns the work when you produce it. And so I would still look at this and make sure it's right, but at least right now it looks right, and it did execute correctly, and we can see certain insights that it's produced. So in this query specifically, Ethereum has these things called transaction types. It could be somewhat interesting to understand how much gas they typically use, and then this final column is the average gas as a percent of a block. So we can see type 3 transactions, which I don't know what those are. I don't know exactly what those are. I think they're EIP 4844 transactions. Are relatively rare, but take up a lot of gas within a block. Transaction type 2, I think, is EIP 1559 transactions, which are kind of the usual transactions, and take up relatively less space. And so this is somewhat interesting, and you can see that having the schema in a text file and being able to add any number of tables to the same text file and reuse it and kind of add to it as you need more and more tables is a really useful thing for speeding up data analysis. And so very happy with this tool, and excited to be able to use it for my day-to-day work and speed that up and become more efficient.